Hi, basically I'm here to give you an intuition behind integration. So let's suppose we will go through a very simple example first. So basically we have a constant function 10. It is continuous, but to get a concept we will use a blocks type. You will get the concept, I hope so. We have continuous signal or a graph 10, and we want to integrate that. So f(x) is equals to 10, and we want to take its area from 0 to 5. So what are we trying to understand here is how slopes, derivatives, etc. is tied with area, how they are linked, how area is linked with derivatives. So basically we are trying to understand this. From 0 to 5 we have 10 dx and 10x. We will get 10x after integration. So what is this function? If we take derivative of this function, we will get 10. But how this function is telling us the area? Like we are putting 5 in this function and the lower limit 0 as well, and it is giving us the area, like this area up till here, like this whole area. How it is doing this? So I have a little intuition behind this, and here it is. So basically what is happening is the 10x function is basically adding all the previous areas. Like this is our original function. So we have a fun block. So at first stage we have the one block. At second stage it is adding the previous stage, this and this, and the second stage this. So basically it is like 1. At second stage it is adding 1 and 2. At third stage it is adding 1 2 3. At fourth stage it is adding 1 2 3 4. At fifth stage it is adding 1 2 3 4 and 5. So basically this 10x function is giving immediate sum of area. At 5 stage we have on original function, at 5 we have this single block, but this 10x function is at 5 it is giving me the whole previous areas. So, and if we want to see 10x, it will be like this. So at 5 it is giving me 50 area, and at, for example, 4 it will give me 40. So for example, if we have limit 3 and we want to understand that why do we minus, so that's the reason basically. So at last we have the full length and we are trying to minus the area we do not want. Like we have, for example, limit, like I want to add this area only. Okay, so I have to minus 5 minus 3. Basically we have this full area and I want to minus this area. So I will get this 20 area and this 30. So by applying limits we are minusing the area. So basically the function that we get after integration, it is with respect to x, it is giving us the immediate areas at that point, and that's why it is like a function of areas, you can say. And this is the same concept in probability. If you have studied probability CDF, it is the same concept basically. Like at x, it gives the immediate area of our original function, and that's why we have these limits and we subtract uh, uh, different things like 10, 5 minus 10, for example 4. Like I'm trying to minus areas, uh, previous areas 10 from the all the area, so I get 10. This concept can be applied on anything. For example, we have a linear function, original we have linear function, and so our integration function will be exponential. For example, we have original function x. If we take its derivative, we get x squared by 2. We get an exponential function. So what is happening, that we have these areas that are linearly increasing. In first example, we have uniform areas that are keeping uniform, but here these areas are increasing linearly. If we add these areas, they will explode exponentially. Like this function, the integration function gives us the exponential areas, and that's how we get this. So basic, in summary, what is happening, that the function the function after integration basically gets us the immediate area. Like this is the function of areas, this is the function of areas, and that's why we minus and this thing works. Thank you. If you have some comments, please give the comments, and if you want to understand some other concept, I will try to make the video for that.